Hello, everyone, and welcome to the National Government webinar series. Happy that you have chosen to spend some time with us today to learn about ArcGIS Earth. My name is Darren Pussum, and I'm the product manager on the Geo-enabled systems team here in Redlands, California. I focus on products for collaboration, situational awareness, and event-based decision-making. Today, presenting with me is Steve Hayes and Stuart Penninger. Why don't you guys give a brief intro, Steve?
Hi, thanks, Darren. My name is Steve Haynes. I'm also a product manager on the Geo-enabled systems team here at ESRI with a specific focus on ArcGIS Earth. Happy you guys have all chosen to join us today and excited to give you some more information. Stuart?
Thanks, Stephen. Hi, everybody. My name is Stuart Penninger, a solution engineer on the National Government team out of Washington, D.C. I look forward to presenting today, and I'm excited to show you some of the really cool things we can do with Earth. Thank you.
Awesome. Thanks, guys. So during today's session, Steve will give you a solid introduction to ArcGIS Earth, and Stuart's going to do a really exciting demonstration, combining many of the ArcGIS cool features by recreating some historical events. But before we get started, though, I'd like to take a minute to take care of a few housekeeping items. Please use the chat window to ask questions if you have anything about the webinar, and also questions about ArcGIS Earth. We've allotted some time for Q&A towards the end of the presentation. I will be happy to take those at that time. And there's a survey at the end of the webinar that you can fill out that will really help improve sessions like these in the future. ArcGIS Earth is a really complete system for globe-based exploration and communication, and a truly immersive 3D editing and analysis experience. If you work on a desktop in the office or a mobile device in the field, you can deploy Earth to complete your tasks. As GIS is rooted in science, in the science of geography, so too ArcGIS Earth enables users to integrate many types of data and work with high-end 3D capabilities on the globe. ArcGIS Earth is setting a new trend when it comes to 3D apps and enables self-service by providing a mechanism for collaborators to securely access and share content for 3D visualization when offline or even behind firewalls. I'd first like to provide a bit of background on ArcGIS Earth, its users, and some of the key requirements we're hearing from users. And then I'm going to pass it to Steve and Stuart for a close-up view of Earth to show you how easily deployable this powerful app is in your organization. ArcGIS Earth is a free native KML application built from the ground up on our ArcGIS runtime. And the latest release 1.10.1 gives users the power and the flexibility to edit KML and work with it directly on the globe. Earth users are combining KML with content from ArcGIS, as you'll see shortly, such as web maps and web scenes, and REST services that can then be used for research, for planning, and presentations. And with mobile scene packages created using ArcGIS Pro, users are taking their work offline and onto their mobile devices and into the field. And if I can share some statistics, we have over 5,500 organizations in 137 countries already using ArcGIS Earth, and downloads for both desktop and mobile continue to climb. Additionally, we have seen huge surges in mobile downloads in Europe during the outbreak of COVID. Ultimately, there's a bigger group of users that ArcGIS Earth serves, but the core user group is really the industry specialists, whether that be an all-source analyst, a planner, an engineer, or educator, and whether they work in an office or in a field. This just means that as a free product, ArcGIS Earth is serving a wider population with content that has already been created by the GIS professionals in your organization. And just to wrap it up, and before I pass it to Steve, KML is one of the biggest reasons we created ArcGIS Earth, and rightly so, as there are legacy systems, as you know, scattered across the national government spaces that still build out these KML files. But in addition to KML, users also need to create content for offline use, use analytical tools to do 3D measure, line of sight, education, elevation profiles, and quickly create content for time-sensitive briefings. Simple tools to sketch and to edit on the globe, and they also want to fuse together content created by others in and outside of the organization. In the architectural construction and engineering world, the AEC world, there's also a high demand for exploring underground, viewing BIM models and CAD models, and doing cut and fill. And developers and system integrators need to customize and configure Earth. Now, let's take a closer look as Steve walks us through some of the key features of Earth.
Thanks a lot, Darren. So ArcGIS Earth has a simple and clean user interface. It's intuitive and super easy to get started with. We made an onboarding experience that highlights the key features and where they're located and what they do. And knowing that each organization has its own lingo, we added a customizable startup configuration file that you can edit to make the startup experience even more familiar to your users. And once your users get comfortable, they can change many of the settings to match their own working environments, including measurement units and navigation speed, adding the option to open web results in an external browser, creation of a custom startup view, and the ability to switch between WebMercator and WGS 84 projections, and many more. So now that we have a good understanding of how Earth is kind of deployed and we want to take a little bit more time and show some of the cool features that really makes ArcGIS Earth stand out, really beyond simply being able to handle KML and KMZ files. So such as being able to switch base maps at will. Being a GIS guy, this is one of my favorites as it provides context to all the information I'm sharing. And it's just a simple click to change. Users can elect to use their own base maps, select it from ArcGIS Online, Enterprise, or from offline files, which can be KMLs, scene layer packages, tile packages, or rasters. So elevation surfaces define height values across the extent of a map or scene, and ArcGIS Earth uses ESRI's World Elevation Service as default. But users can add their own terrain surfaces in a similar manner to base maps as well. So one of the initial releases of ArcGIS Earth, we added the vertical exaggeration feature. Users got an on-canvas control that enables interactive manipulation of terrain. So with this tool, you can emphasize areas with subtle variations in height or flatten surfaces to assist visual data exploration. Sometimes when these adjustments are made, it's hard to appreciate the reality of the elevation, but when combined with base maps, such as a topographic map, contours depict the actual elevations, which is just another way which combining these incredible features of ArcGIS Earth helps you tell your story. So bookmarks are another one of the great features that you've asked for and we've incorporated in ArcGIS Earth. So with bookmarks, you can save your favorite spots around the planet and click on the thumbnail and fly to that location. You can easily edit a bookmark's name, reorder, and play the entire list during your presentations. So ArcGIS Earth can access multiple types of data from many sources, such as ArcGIS Online, ArcGIS Enterprise, via URL or locally on your desktop or a local file server. So as mentioned before, KML is one of the biggest reasons we created ArcGIS Earth, and it certainly satisfies that requirement. But ArcGIS Earth offers up a whole lot more. So it enables users to combine or fuse together their warehouse of data stored in ArcGIS Online and Enterprise, and even open source, such as different OGC supports, all with KML. So ArcGIS Earth can consume traditional GIS like shapefiles, ESRI services, including feature, image, map, and scene services, imagery and base maps and terrain, 3D models, CSV and text files, web maps, web scenes, mobile scene packages, point cloud scene layers, 3D point scene layers, data from the Living Atlas, and all sorts of open source data, such as WMS, WMTS, and we're adding much more, such as WFS, in this upcoming release. So let's take a deeper look into all the different types of data that ArcGIS can consume. So we've got native support for KML, including creating, editing, and saving, but we've also got support for the network links, time sliders, and adjustable data refresh rate. We've got access to the sublayers and the ability to play tours and call external services. We can add hyperlinks and capture snippets. We can change transparency. We can create and modify feature geometry, screen overlays, ground overlays. We can edit in the table of contents, and we gracefully handle all errors. Additionally, ArcGIS Earth also has full support for ESRI REST services. Users can identify and display metadata and attribute information for map services, image services, as well as WMS services anywhere on the globe. And ArcGIS Earth supports 3D scene layers as well. It's able to view a variety of 3D content in the same manner as other applications across the platform, including 3D objects and integrated mesh scene layers, point clouds, and 3D points. And users can consume these layers as services or locally as a scene layer package file. So being a part of the ArcGIS platform absolutely has its benefits, as users can access and view web maps and web scenes available on ArcGIS Online directly in ArcGIS Earth. And as mentioned, users can also work with several 3D model formats, including 3ds Max, Collada, DAEs, Autodesk FBX, and many more. And you can configure 3D model properties using general, view, and info tabs. And you can add text, change locations, altitude, and views. And once you finish adding a 3D model, it'll appear in the table of contents as a new layer, and you can then export that as a KMZ for sharing. Such as this model in this example, which is actually a KMZ of the current sunken state of the Titanic. And this is being rendered in ArcGIS Earth. So there are many different types of raster data supported in ArcGIS Earth, including DTED, GeoTIFF, Mr. SID, NIDIF, etc. And users can control opacity, brightness, gamma, and transparency on local rasters, as well as on rasters loaded from image services. So we've also got the ability to parse and display textual data. Users can simply drag and drop a text file or a CSV file directly into ArcGIS Earth. In this example, after dragging and dropping a CSV file, you can combine geocoding functionality to visualize the textual data, including adding symbology. ArcGIS Earth uses ESRI's World Geocoding services to find addresses, cities, landmarks, business names, and postal codes in more than 100 countries around the world. But users can add their own custom geocoder as well. So one of the key differentiators in ArcGIS Earth is its ability to provide users to perform high-end 3D analysis. So we've got an interactive 3D measurement tool where you can measure distances dynamically on terrain, buildings, or other 3D objects. We give you the option to gain greater insight of an environment, say before a hike, using an elevation profile tool to create a profile graph from terrain or surface data using ESRI's World Elevation Service or your own proprietary content. So you can do this dynamically, as shown in this example, or from any data that you've got added in your table of contents. So with line of sight, you can perform an anticipatory line of sight analysis from a point or a camera, and you can play animations. You can determine the visibility based on elevation of all the points in a straight line on a surface between an observer and the target points, and how those update over time. So we can determine the viewshed of a geographical area that is visible from a location. You can see all the surrounding points that are in line of sight with that location, and none that are beyond the set horizon or obstructed by any terrain or feature data. So now let's take a quick look at the different types of configuration patterns that we're seeing with ArcGIS Earth today. So one of the largest deployments of ArcGIS Earth stemmed from the need to work securely behind a firewall at many government agencies, both here in the US and around the world. And I can say ArcGIS Earth is secure and easily deployable. So ArcGIS Earth supports multiple authentication patterns, but what's significant for our national government users is that with ArcGIS Earth configured to point at a PKI-enabled portal, for example, they'll be automatically signed in with their credentials. So as an administrator, you can configure settings with a configuration file to meet your organization's requirements. Admins can use the configuration file to change settings without recompiling the application. Administrators can access the config.xml file in the installation directory and specify values for corresponding attributes to customize a preferred startup setting by changing configurable parameters. It is also possible for users to set some policies that affect how ArcGIS Earth runs on their machine. And there's an ArcGIS Earth sample configuration file that can be downloaded to get you started. So we can also connect securely to an ArcGIS Online and access hosted content by ESRI. Additionally, you can combine content from both ArcGIS Online and ArcGIS Enterprise in a more hybrid approach. And if you're wondering, ArcGIS Earth can also be deployed in a virtualized environment, such as with AWS and Microsoft Azure. So Earth's offline capability has significantly improved with mobile scene packages, which has really put us on equal footing with the Fusion server process. And though we still have a bit to go in terms of package file size, we've made a big leap in making this process much more efficient. Our users can now add several layers, including scenes and terrain data, into ArcGIS Pro, and then search the tools menu for the Create Mobile Scene Package tool. Once that's selected, just fill out some simple data fields and create a mobile scene package, which can then be loaded directly into ArcGIS Earth. So, as previously mentioned, in terms of disconnected workflows, we added the mobile scene package support, and there are plans of bringing additional functionality to make it easier to author and consume mobile scene packages across the platform. So ArcGIS Pro creates a mobile scene package file from one or more scenes for use across the platform. And then the mobile scene packages can be used by developers building applications with ArcGIS Runtime SDK, hence the reason we can have it in Earth today. And it's really simple to create, as I said. It's all part of our powerful processing toolkit. So you can use the interactive edit tool to define an area of interest by drawing a rectangle on the ground of the scene. If an extent's not specified, the current scene extent will be used to define the area of interest and consolidate only those features that interact with that extent. Then the mobile scene packages are then optimized for 3D visualization, and multi-patch feature layers, 3D point feature layers, and last dataset layers will be converted to scene layer packages for faster drawing. So ArcGIS Earth is also available on your mobile devices. ArcGIS Earth Mobile extends the capabilities of the desktop version right to your fingertips, enabling the ability to visualize, analyze, and share data anytime, any place. Mobile users are able to browse 2D and 3D content and visualize right on the globe, add place marks and share KMZ files, perform all the same interactive 3D analysis, including point measurement, line of sight, and viewshed analysis that you can perform on the desktop. Additionally, mobile users can geotag their photos and create virtual tours. ArcGIS Earth Mobile is available for free download on the Google Play Store, App Store, for Android and for iOS users. And I know I crammed a lot of content into a short amount of time there, but now that we've given that overview of some of the features of ArcGIS Earth, I'm going to hand it over to Stuart, who will be demoing this functionality in real time.
Thanks, Stephen. I appreciate the introduction. As I said at the top of the broadcast, my name is Stuart Penninger. I'm a solution engineer out of Washington, D.C., and I'm excited to show you some really cool features in ArcGIS Earth today. So, like some people on the East Coast, my family and I spent some time in the Outer Banks to enjoy our summer vacation. The popular island chain off the coast of North Carolina sees thousands of people a year who flock there to enjoy the warm sunshine, great beaches, and laid-back way of life. But these islands have a darker side. Not far offshore, sometimes within sight of the beach, lies the graveyard of the Atlantic. Today, using ArcGIS Earth 1.10.1, we're going to step back in time to see treacherous pirates, daring naval battles, and how a small island chain off the coast of North Carolina played an oft-forgotten role in World War II. In ArcGIS Earth, I can drag and drop KMLs and KMZs easily. This KML will populate in ArcGIS Earth. Looking at this KMZ or KML, I notice that the icons are not applicable for a shipwreck. I can open the KMZ and begin to modify the icon. I can choose a default icon or a custom one that's more applicable for a shipwreck. Once I do that, I'm able to quickly save this out and share it with people in my organization. Not only can we live in the two-dimensional realm with ArcGIS Earth, but we can also enter the third dimension. Let's take a look at Blackbeard's crown jewel, the Queen Anne's Revenge. As part of ArcGIS Earth, and as Stephen mentioned, we can add DAE, FBX, and OBJ. And the Queen Anne's Revenge right here is an FBX, and we can add it and then manipulate the size, the scale, where it's located. And this allows us to visualize models throughout history or of things happening right now. This ship was run aground in Beaufort Inlet in 1718 and sunk. Blackbeard abandoned the ship to retire from his life as a pirate, or that's what he told the governor of North Carolina and Virginia. He would return to piracy only a couple months later. Why don't we go ahead and fast forward a year to 1719 and take a look when Blackbeard was back to his pirating activity. Blackbeard was pursued by young Lieutenant Robert Maynard. So we can go ahead and drag in a KMZ of his ship and see what it may have looked like when he ran into Blackbeard that night in April of 1719. The fighting was rumored to be incredibly close. The ships almost crashed at one point. So why don't we take a look and see how close these ships really got? Using the measure tool in ArcGIS Earth, I can see the distance between these two ships. And at 4.94 meters and at about 16 feet, these ships were incredibly close and the fighting was heated. Not only do you have to listen to me explain to you about the last stand of Blackbeard, we can go ahead and add a screen overlay and provide further context to what's happening. We can adjust this and sticky it to this side of the screen. And as we begin to move around these ships, that image will hold in place so that we have a better story to tell and more context to be added. Blackbeard's pirate luck ran out that day, and the Royal Navy emerged victorious. But this would not be the last battle off the coast of North Carolina or in the Outer Banks. Let's jump 220 years in the future to World War II to see how the U.S. Navy battled with German U-boats prowling the coastal waters of North Carolina. After entering World War II in late December 1941, the U.S. Navy and the U.S. military as a whole were a bit underprepared in terms of their defensive and offensive plans. Since I'm connected to my organization, I can add data that allows me to visualize these early naval defensive areas. These defensive areas allow me to see exactly where Navy ships may have been looking for U-boats and how they would clear these sectors when they would go out on their daily patrols. These green sectors are interesting to look at, but what this really makes me want to investigate is, what did these Navy escorts look like? So let's go ahead and take a look at them. These large U.S. Navy destroyers were tasked with defending the Outer Banks during World War II and protecting merchant ships. But there's only 2 of them here. Why don't we go ahead and add one of the most famous U.S. fighters during this time, who was the first to sink a German U-boat during World War II? Let's go ahead and add the USS Rover to this scene. When I select this, I notice that this KMZ doesn't have any useful information. So why don't I go ahead and come into the properties, edit the info, and add a quick description, which will give me key descriptive information regarding this ship. This will allow me to share this information widely with other people in my organization, and now they may know what this ship did and a little bit of the background information. But the war was just not fought at sea. It was also critical that aerial reconnaissance was used to ensure that U-boats weren't sneaking in and out of the Sound into the ocean to ambush merchant ships. Using the Viewshed tool, I can create animations of reconnaissance flight lines flown by Navy pilots. So let's go ahead and see exactly what this pilot would have seen. Using the parameters, I can modify and change exactly what this plane saw as they flew around the Outer Banks and searched for U-boats. And I'm going to let it turn right there, and we're going to follow it as it heads out to sea to join that Navy escort and search for U-boats out in those defensive areas we added earlier. And as we turn, we can see the plane head straight out for that destroyer. But the fight didn't end there. It wasn't just at sea. It wasn't just in air. Let's take a look at what the men and women on the ground saw as they went to battle. The men and women in the Outer Banks and the military position there used large 88mm guns to defend their islands from U-boats entering critical infrastructure areas. Artillery was positioned on the beach and near harbor entrances to deter U-boat activity. They were at times positioned on platforms to gain a better vantage point over the Sound. We can recreate these platforms using ArcGIS Draw tool. We'll create a polygon. We'll make it absolute. We'll make it 5 meters high. And we'll extend it all the way to the ground. Now we've created a pillbox. Once again, we can maneuver these models that we've already added. So we'll come into properties, and then we'll change the altitude of this gun position so we can slide it on top of our new pillbox. Once we do that, we have now created a U-boat deterrent gun position that may have existed in 1942 as we're seeing it today. Next, we can create a line of sight to see exactly what that gun saw. We'll select out. We'll look and create a couple draw points to see exactly what that gun could see. And now we can select and maneuver this point and use that analysis that we just conducted for that gun and share it along the other 2 artillery emplacements. Now, let's see the last line of man-made defenses for the Outer Banks. If a U-boat were to make it past every ship, plane, and artillery placement, they would still have to deal with sea mines. Let's go ahead and drag a KMZ of sea mine locations into ArcGIS. As you can tell, we can't add that. We're missing some key information in our KML. And thanks to inline error handling with ArcGIS Earth, we can go ahead and open our text editor and see what's exactly going on because it tells us line 3, position 2. So let's go ahead and check that out. We pull up, we see that we're missing our document. We select save. And now let's see if that KML will load for us. Now we have our sea mine location. But if you're asking me, I'm not too fond of that symbology of those icons. Let's see if we can add sea mines another way. In ArcGIS Earth, we can also add services from a REST endpoint. So let's go ahead and do that. And when we add that, it'll automatically populate with our service. And we've already gone ahead and loaded this in. So let's take a look at it. And now that symbology looks a lot better. It actually looks representative of what a sea mine would look like. And so we can add data a whole bunch of different ways, whether that's through a KML or a KMZ or adding something from or adding a layer from a REST endpoint. Now that we've seen the man-made defenses that went along during World War II, let's check out some of the ships that comprise the graveyard of the Atlantic. During World War II, the graveyard of Atlantic earned its name. German U-boats and U.S. Navy vessels played a game of cat and mouse as they tracked each other up and down the coastline. U.S. Navy ships avoided serious damage, but merchant ships were not so lucky. Let's go ahead and review the story of the HMS Splendor. And as we mentioned earlier, we can drag in different 3D models and alter their appearance. So let's go ahead and do that with the HMS Splendor. And when it's added, it doesn't seem to be at the appropriate scale. So let's go ahead and manipulate that to make it more appropriate for this scene. As we now see, the HMS Splendor has been added to our scene, and we can see exactly what this ship looked like the day it sunk. And once we've seen this, we know that German U-boats were prowling it because it was a merchant ship that transported oil back and forth from the United States to England to support Great Britain during the Blitz. Let's go ahead and take a look at what the Splendor may have looked like, what the Splendor may look like today laying on the ocean floor. Once again, as we give the model a second to load, we can insert a screen overlay of exactly what the HMS Splendor looks like today. And when we maneuver and move around, this screen overlay is going to stay in place the entire time. And this allows us to view exactly what may be happening during what a diver may see today. And coming in ArcGIS Earth 1.11, you'll be able to dive beneath the waves and really take a look at this model where it really rests today. And so let's talk about one more shipwreck that comprises the graveyard of the Atlantic. And let's return to one of the ships we saw earlier, the USS Rover. And We used the Viewshed tool earlier to show how a reconnaissance pilot would search for U-boats in the sound over the island and in the ocean. But let's use it one more time to see the torpedo that was fired from the USS Rover into the side of U-boat 85. We'll select the torpedo line. We'll increase the speed to show you how quickly a torpedo actually moves through the water. And we'll start the animation and zoom in. U-boat 85 had no idea this torpedo was fired from the USS Rover. It didn't even realize it had been shot yet. And as you can see in this viewshed, the torpedo is only seeing what's right in front of it. It's only sensing what's right there. And it will emerge from the darkness of the sea to blindside U-boat 85. And now you can see as the torpedo gets closer, the broadside hull on the port side of U-boat 85 becomes readily apparent. And at this moment, parts of U-boat 85 are in the Hatteras Museum of the Graveyard of the Atlantic, and you can go there and see it today. And it's funded in part by support of the German government. But torpedoes were dangerous. But the natural hazards of the Outer Banks also contribute to the defense of the islands during World War II and the many shipwrecks in the Graveyard of the Atlantic. U-boats and pirates alike found it difficult to navigate these ever-changing channels and inlets. Let's go ahead and investigate these natural hazards. In ArcGIS Earth, we can drape raster data sets over our scene. Thanks to NOAA, we can bring in nautical chart image services to explore what the channels, harbors, and inlets look like today. We can take a look and see the treacherous nature of these channels that lead into Ocracoke Harbor and Silver Lake. A channel that at some points is 22 feet deep is now 3, 5, and 1 foot deep in the snap of your fingers. And this made it incredibly difficult for German U-boats to enter critical infrastructure areas and attack the Outer Banks themselves. And if I want to continue to investigate this data, but what if I'm not at my desk? What if I wanted to explore these waters myself and take this information with me out into the field? ArcGIS Earth is not only a desktop application. The mobile application allows us to take Earth on the go. Just as in the desktop version, I'm able to connect to my organization through my login and password. I can also add data a few different ways. I want to head out on the water later, so the NOAA navigational charts would be invaluable to me. So let's go ahead and add those through a QR code. And now they've been added. So let's use our place marks and let's go see the same exact spot we saw on desktop in the mobile application. And as this image service loads, we can see the exact same thing we saw on desktop in our mobile application. But I want to know where these shipwrecks are. I want to see the Graveyard of the Atlantic for myself. So I can come back in to add data. I can add an item from my portal content. So I'll come over to my content and I'll add the Graveyard of the Atlantic ship locations where they rest today. And when I add that mobile scene package, it's going to show me where these ships are. Let's go ahead and change the base map to something more appropriate. And let's take a look at one of these ships here. I've selected the F.W. Abrams, a U.S. merchant marine vessel that was sunk in 1942. When I select that shipwreck, it's going to give me the pop-up with key descriptive information. And it's going to provide me the history of that ship right then and there. Now that I've added this information and I know exactly where the ship is, say if I was a scuba diver or a fisherman, I could make my way out to that shipwreck and begin to investigate it for myself in person using ArcGIS Earth mobile application as a guide. And now I've gone ahead and shown you ArcGIS Earth desktop and mobile. I'm going to go ahead and turn it back over to Stephen to show you what's going to happen, where we're going with ArcGIS Earth 1.11.
Thanks a lot for that awesome demonstration, Stuart. That was really, really cool. And since we've got a new release scheduled for next month, I'd like to take a few minutes to give a bit of a sneak peek to some of the updated features and functionality that we've got coming up in ArcGIS Earth 1.11. So with the release of 1.11, you'll now have the ability to layer dynamic sunlight and shadows onto your scenes, which can be easily updated to reflect dates and times in any time zone. Got a cool functionality where you can actually play this over the course of a day or over the course of a year, as shown here in this GIF. Additionally, we went over bookmarks earlier and how that's a key functionality of ArcGIS Earth. But in 1.11, our teams completely redesigned the UI and UX around the bookmark functionality, allowing the ability to create and manage multiple bookmark groups. My favorite update, however, is the informational pop-ups. We've added a simple way to rapidly add additional context with these sleek pop-ups to your bookmarks by filling out a simple form to customize the look and information you'd like to share. And another highly sought after feature that will be available in the upcoming 1.11 release is underground navigation. So we've added the ability to go underground and view a multitude of different subsurface data types, such as this BIM infrastructure data in Rotterdam, Netherlands. So you could also imagine in the demo that Stuart just gave, the ability to load in bathymetry data and then truly go under the sea and check out where those shipwrecks currently lay. So in closing, I'll review the current roadmap for ArcGIS Earth. So 1.11 is going to fall in the near term, say post-UC category, and that's some of the features that I was just showing you. So in addition to all of our KML editing and the ability to take in a bunch of different data types, with 1.11, we're going to be releasing support for additional data types, such as GPS and GeoJSON and WFS, underground navigation, as you just saw, as well as sunlight and shadow. We'll have more symbology methods and a redesigned bookmark and pop-up functionality, accessibility enhancements, tablet support, and an updated developer experience. In our mid to longer term, we're looking at adding additional data type support, new interactive tools, movie maker support in the tool, an imagery selector with time slider functionality, the ability to configure and share data back to the portal, 3D labeling, Chrome OS support and web support, as well as an SDK. So again, ArcGIS Earth is free to download and use. It's a powerful, lightweight 3D visualization and sharing application available on desktop and mobile, with connected and disconnected workflows and native support for KML and much more. So we encourage you to try it today on our website, the Microsoft Store, the Google Play Store, or the Apple App Store. Additional resources are available at the following links, including our website and blog posts. And we're always happy to receive feedback and have listed several ways in which you can reach us.
Great, thank you, Steve. And thank you, Stuart, for that great demo. Now, I'll open up for some questions. I saw there were some online. I tried to answer as much as I could, and I'll open the floor to any questions you have for the team. Okay, so if while you guys are getting your questions together, let me try to answer some that I've seen online. So someone asked, how are the 3D models added? Well, as you could see what Stuart did. Stuart, do you want to explain how you added your 3D models and the types?
Yeah, absolutely. So we can add DAE, FBX, OBJ models, and really what I did is I downloaded 3D models, saved them into a local space, and then just dragged and dropped them into ArcGIS Earth. And when you do that, they're going to populate, and you can manipulate the scale, the heading, and you can provide descriptive information about them. So you could add any model you like. So I know that I added a couple pirate ships, Navy ships, sea mines, and there was even a joke or two about adding a Kraken in there as part of the pirate story. But I refrained from that. So you can really add any model you'd like to. Anywhere you can find 3D models and can download them that are OBJ, DAE, or FBX, you can add them into ArcGIS Earth.
Someone wanted to also know, how did you get the model to the exact location you wanted?
Yeah, so I moved those models using the Latin long of the current shipwrecks. And so like the USS Roper and U-boat 85 collision and battle, I didn't know exactly the coordinates for where the Roper was or where the U-boat was. I just did a little bit of research and read the reports about it and kind of recreated it to the best of my ability. The other point of the pirate ships and the graveyard of the Atlantic is that if you search the Living Atlas or ArcGIS Online, there are also maintained feature layers that show where these shipwrecks are. So I manipulated and dragged and dropped the models exactly where those shipwrecks were. So that way I try to keep as much location accuracy as possible and kind of tell the best story that way.
Awesome. So I had one about archaeology. Someone asked that they were using ArcGIS for archaeology to understand the Neolithic deposits. So they wanted to know if they could understand underground deposition of evidences like stone tools, etc. Steve, you want to take that one?
Sure. I think for this question, so you can understand the underground deposition of it. So what you could use it for would be, what the real value would be, visualization of how those deposits lie, to tell your story about where those evidences of stone tools would be. I don't know if it's got so much of the analysis functionality quite yet, but I think from a visualization perspective, it could definitely be helpful.
And can topographic profiles be exported to other platforms? So right now, the elevation profile could be exported just as a PNG file or a JPEG, but we're working to extract that so that we could use it to other platforms. Can you create threat domes in Earth? Well, so far we've added the line of sight and Viewshed, but we do have threat domes on in our backlog. And someone asked,
actually, I'll add a little bit to that,
sure.
Darren, if you don't mind. So yeah, threat domes is actually something that was also just released in Pro. So that's something that we'll probably look to add in sooner than later into Earth. It should be relatively easy and coming soon, I would say.
Yeah. And someone asked if there were shortcut keys in Earth. Yes, there are many shortcut keys. If you go to the doc page, there are many shortcut keys that you can use. And incidentally, one of the easiest tools what I found after teaching my daughter's class is that they're similar to Minecraft for navigation. So if you have you have kids that use Minecraft, they're similar tools for the navigation, but there are other keys as well. Steve, how can you add LiDAR data to use on a mobile version?
Yeah, so right now the best way to do that is taking advantage of a scene layer package file or a mobile scene package file would be my suggestion for those.
So there was one question I think we maybe need a little more explanation. Can we link ArcGIS Earth with ERDAS to extract any special feature? So if you want to clarify that question for us, Jenny. Okay, so ArcGIS Earth, there's many different types of data that you could include. If ERDAS has a format that ArcGIS Earth accepts, you simply have to add it into Earth to visualize it. There was one question, where do I get the 3D sea mine symbology? Is it part of ArcScene symbology? ArcScene and ArcGlobe are older 3D viewers. Earth is the new 3D basically platform for 3D. ArcGIS Pro is as well.
Yeah, and I believe that particular 3D sea mine symbology, those were actually 3D models that Stuart took and placed like via geospatial data and saved out as a KMZ, so they showed up that way. If I'm not mistaken, is that correct, Stuart?
Yeah, we created it in ArcGIS Pro in an edit session. Just we dropped points along where mines were during World War II, and then we created custom symbology in ArcGIS Pro, and then published that to our portal, and that's where I brought it in from ESRI.
Great.
Yep, and someone also asked about geocoding. Yes, geocoding will consume credits for online, but you can basically use the ESRI's World Geocoding Services to find addresses, cities, landmarks, and so on. Or you could even configure your own custom geocoder services enterprise for GeoSearch or geocoding or both. Okay, we have about 5 minutes left. I see, is Earth replacing ArcScene and ArcGlobe completely? I would say you have two options to replace 3D, and that would be ArcGIS Pro and ArcGIS Earth for the desktop version and our scene viewer on the web. How often are base maps updated, especially for large African cities? Well, I believe there's a time frame for updating base maps. I want to say it's twice a year, but I will have to find out about that. And that's across ESRI. Okay, great. Well, thank you folks for attending today. I believe we have a short survey that we'll be sending out right after the webinar is ended. I'm happy to have been able to present here with my colleagues Steve and Stuart, and I hope you enjoyed the session. Our emails are on the PowerPoint there, and I believe we'll be making this available for everyone. Thank you.